Network Plus course. Network attached storage. The most common type of server found on networks is the file server. File servers are typically the most accessed servers of all, storing files for all the users on the network. Traditionally, these servers are just computers running a special network operating system that allows files and programs to be shared. Additionally, these servers cost several $1,000s. In the last few years, however, it has become very attractive to network administrators to replace these file servers with a new breed of device known as network attached storage. Network attached storage, such as the quantum server, is basically a small network device or black box with a network card and a large hard disk. The network attached storage device usually runs a special proprietary operating system that allows the box to function as a file server. The main reason these devices are so attractive to network administrators is that they are very inexpensive compared to traditional file servers. For example, a typical Pentium 2 server with 256 megs of RAM might cost a few $1,000s. On the other hand, a 20 gig network attached storage device might cost only a few $100s. Another advantage to these devices is that they are very easy to administer. Usually security and access are set up by connecting to the device with a web browser and making changes using a web interface. The final advantage to these devices is their ease and speed of setup. It would take most network technicians about 3 hours to add another server to a network. Quantum, however, expresses setup times for its network attached storage device in minutes and seconds. Basically, all the administrator has to do is plug in the power, plug in the network cable, turn on the device, and set up security access, and the device is ready to use. So I suppose this would be an example, I suppose, of network attached storage. Here's you see the servers, and here's the network attached storage device. Okay, physical topologies. A topology is basically a map of a network. The physical topology of a network describes the layout of the cables and workstations and the location of all components. Often, physical topologies are compared to logical topologies, which define how the information or data flows within the network. The topologies are usually similar. It is important to note, however, that a network can have one type of physical topology and a completely different logical topology. The cable or connections in a physical topology are often referred to as network media or physical media. Choosing how computers will be connected to the company's network is critical. A wrong decision in the physical topology makes the media difficult to correct because it is costly and disruptive to change an entire installation once it is in place. The typical organization changes the physical layout and physical media of a network only about once every 10 years, so it is important to choose a configuration that you can live with and that allows for growth. In the next section, we'll look at physical media. We'll look at the 5 most common topologies: bus, ring, star, mesh, and wireless. In a bus topology, all computers are attached to a single continuous cable that is terminated at both ends, which is the simplest way to create a physical network. Originally, computers were attached to the cable with wire taps. This did not prove practical, so drop cables are now used to attach computers to the main cable. Notice how the cable runs from computer to computer with several bends and twists. So this is an example of a bus topology network. Here is a coaxial cable, and then a coax cable then goes to the desktop machines. When communicating on a network that uses a bus topology, all computers see the data on the wire. This does not create chaos, though, because only one computer that actually accepts the data is the one to which it is addressed. You can think of a bus network as a small party. As with most things, there are pros and cons to a bus topology. On the pro side, a bus topology is simple to install, relatively inexpensive, uses less cable than other topologies. On the con side, a bus topology is difficult to move and change, has little fault tolerance. A single fault can bring down the entire network. It is difficult to troubleshoot. Star topology. Unlike those in a bus topology, each computer in a star topology is connected to a central point by a separate cable. The central point is a device known as a hub, although this setup uses more cable than a bus. A star topology is more fault tolerant than a bus topology. That means that if a failure occurs along one of the cables connecting to the hub, only that portion of the network is affected, not the entire network. So this here is a picture of a star topology network. Here you have your switch or hub at the center, and Cat5 Ethernet cables then are going from the hub or switch to Ethernet cables in the back of these desktop computers. The design of a star topology resembles an old wagon wheel with wooden spokes extending from the center point. The center point of the wagon wheel can be considered the hub. Like the wagon wheel, the network's most vulnerable point is the hub. If it fails, the whole system collapses. Fortunately, hub failures are extremely rare. As with the bus topology, the star topology has advantages and disadvantages. The increasing popularity of the star topology is mainly due to the large number of advantages, which include the following. New stations can be added easily and quickly. A single failure won't bring down the entire network. It's relatively easy to troubleshoot. The disadvantages of a star topology include the following. Total installation costs can be higher because of the larger number of cables, but prices are constantly becoming more and more competitive. It has a single point of failure, the hub. In the ring topology, each computer is connected directly to other computers in the network. Data moves down a one-way path from one computer to another, as shown in figure 1.7. The good news about laying out cable in a ring is that the cable design is simple. The bad news is that, as with a bus topology, any break, such as adding or removing a computer, disrupts the entire network. Also, because you have to break the ring in order to add another station, it's very difficult to reconfigure without bringing down the whole network. For this reason, the physical ring topology is seldom used. So this here is a picture of a ring topology. I suppose each computer would have a network card, and then cable then goes then from computer to computer. Although, as its name suggests, a relationship, Token Ring does not use a physical ring topology. Instead, it uses a physical star logical ring. Few pros and many cons are associated with a ring topology. On the pro side, the ring topology is relatively easy to troubleshoot. A station will know when a cable fault has occurred because it'll stop receiving data from its upstream neighbor. On the other side, a ring topology is expensive because multiple cables are needed for each workstation. Not fault tolerant, a single cable fault can bring down an entire network. Mesh topology. In a mesh topology network, a path exists from each station to every other station in the network. While not usually seen in LANs, a variation on this type of topology, the hybrid mesh, is used on the internet and other ones in a limited fashion. Hybrid mesh topology networks can have multiple connections between some locations, but this is done only for redundancy. Also, it is not a true mesh because there is not a connection between each and every node, just a few backup purposes. So this here is a picture of a mesh topology. You can see it's very highly redundant because you have many cables. So if one cable goes down, another one is able to come in. Today the mesh topology is rarely used, and then only in a WAN environment, and only because the mesh topology is fault tolerant. Computers or network devices can switch between these multiple redundant connections if the need arises. On the con side, the mesh topology is inexpensive and, as you have seen, quickly becomes too complex. Now, wireless. Radio frequency RF systems are being used all over corporate America. RF networking hardware that is available today makes it easier for people to connect wirelessly to their corporate network as well as to the internet. The most popular example of an RF network today is what is known as an ad hoc RF network. These networks are created when two or more entities with RF transceivers that support ad hoc networking are brought within range of each other. Two entities will send out radio waves to each other and they will both recognize that there is another RF device close by that they can communicate with. These ad hoc networks allow people with laptops or handheld devices to create their own networks on the fly and transfer data. So this is a picture of an example of an ad hoc network in which each laptop is able to communicate with another. The other example of an RF network is a multiple RF network. This type of RF network has many stations, each with an RF transmitter and receiver. Each station communicates with a central device known as a wireless bridge. A wireless bridge known as a wireless access point or WAP or in RF systems is a device that provides a transparent connection to the host LAN via an Ethernet or token ring connection that uses some wireless method, e.g., infrared or microwave, to connect to the individual nodes. This type of network is mainly used for two applications: office, cubicle farms, and metropolitan area wireless internet access. Each of these applications requires that the wireless bridge be installed at the same central point and the stations that are going to access the network be within operating range of the bridge device. So this is an example of a network. So I suppose we point to multi-point network. There are many different brands, makes and models to RF LAN equipment. This used to be a source of difficulty for LAN installers. In the infancy of RF wireless networking, every company used different frequencies, different encoding schemes, different antennas, and different wireless protocols. The marketplace for was screaming for a standard to be proposed. For this reason, the IEEE 802 standard was developed 802.11 is a networking standard that specifies various protocols for wireless networking. It does in fact specify that either infrared or RF can be used for the wireless network, but most RF systems are the only ones advertising the IEEE 802.11 compliance. So I'm going to leave it there today for this video. If you liked it, please consider sharing, liking, and subscribe. And thanks for watching.